For this example, we're going to access an open source CoreML model repository called Awesome CoreML Models and utilize a model called EmotionNet. I've downloaded the model and I've dragged it into an example project. When you first drag in your model, make sure to take note of the input and the outputs of the model. The input for this model requires an image of the dimensions 224 by 224, and outputs are two outputs of label prob and label class label, that is a string and dictionary. We're first going to create a new class called Emotion Model Definition. You can name it however you deem fit. And we're going to import Polarr Foundation. We're going to create the class by inheriting a class that's a part of Polarr Foundation called Neural Model Definition. This is how you will define how your model is used and how the pre-processing steps should ensue and the post-processing steps should be handled as well. First thing we're going to do is set a path. This is the location of your model. We type in the name of the model, access the specific function of the model, and access the path value of the URL type that's returned from this. We set that to path. There's two type aliases that need to be defined in order for this class to be buildable, and that is of type alias output and parameters. Output is what type the post-processing step should return. The type alias parameter is required if any other parameters are required for the CoreML model to run effectively. Now we're going to instantiate a metal device, a metal command queue, and a scaling kernel. We're going to create a scale texture descriptor of metal texture descriptor type, which we will use for the scaling kernel in order to scale the input texture that we are receiving to the required input dimensions, which is 224 by 224. Let's initialize the variables that we just defined, and that is a metal device, a command queue from the metal device, and a scaling kernel from this function over here by initializing it with device. Make sure to import CoreML and metal performance shaders to access not only this function, but other types that we will deal with. Within the pre-processing protocol stub that is required to implement as part of the neural model definition class, we will handle our input texture in a way so our CoreML model will be able to utilize the input effectively. In order to do this, a basic setup can look like this. We create a command buffer from the queue. We create a texture with the descriptor and call it output texture. We scale the input texture with the following line and setting the destination texture as the output texture that we created earlier. We commit and wait until completed, hence execute. And we're going to make sure that's of type CV pixel buffer, which is provided by the code example below, which converts a metal texture into a CV pixel buffer, which the CoreML model will take in and process effectively. Now we're going to look at the post-processing step. For EmotionNet, it's a simple string, so we set the output as string. If you go into the definition of this class, it's of type alias output, which means that this has to match, we set type alias output to, so it's a string. As you can see, that means we're going to try and access the output known as class label, as we saw earlier in outputs. Now class label is case sensitive, so make sure it's camel case. We're going to make sure it's a string. If it's not, we'll return nil and handle that accordingly later. If it succeeds, let's return the label. Now we can move on to our view controller. We're going to inherit another class that's part of Polarr Foundation that's called Still Image View Controller. This is for handling simple still image uploads and processing them accordingly. There's also Camera View Controller, which handles live video feed. They're both alike in terms of protocol stubs and functions required to be implemented. Let's start off by creating a runnable instance of our model definition class. You do that by creating a neural model runner, which is a part of Polarr Foundation as well, and instantiating it with a type of the class that we just created by calling the class name and .self. Now let's set up some simple UI elements to output the emotion by overriding viewDidLoad, adding a UI label to the subview, and setting some simple constraints so we can see it. Now this is the main or core function that we inherit from still image view controller called process texture. We override it and we can retrieve a texture or a metal texture type that we can now utilize to run our newly created runnable instance, which will send this texture to our model definition. They'll be handled in a pre-processing step. The CoreML model will run the texture or CV pixel buffer that's created, and then the post-processing step will output the required type alias within a completion handler that is accessed from the run-in background function of the motion runner. Motion runner has other run type functions as a simple run, but for now we're going to use run-in background. And then we know emotion is string because we set the output type of our model definition to string. But it could also be nil, so we're going to handle a nil case by saying not detected if it is. Now let's test out our demo app. Oh, and before we finish, make sure to complete this process texture with the texture that is being passed in from the function, as there's a completion handler waiting on the other side. This is the still image demo. We can open an image, upload a simple picture, and we'll see an emotion output over here, fear. That is emotion running successfully under Polarr Foundation's